Great. Great, thanks. So I'm Randy Shoup. I'm currently the VP of Engineering at WeWork, and I want to talk to you today about moving fast at scale. So when we build software products, we're trying to do two things. We're trying to build the right thing, and we're also trying to build the thing right. And sometimes it can feel like there's a conflict there. And that conflict can feel like we have to choose between whether we go fast, whether we have speed, or whether we do things sort of properly, whether we have stability. So it turns out that even though this trade-off seems like it might be intuitive, it turns out that it's actually not true in the real world. So I hope a lot of people here are familiar with the book Accelerate. People familiar with Accelerate? Yes, let the record show that many hands went up, but not enough. So this is Dr. Nicole Forsgren as the primary author, Jez Humble, one of the speakers here, and also Gene Kim. And this book is an amazing exploration of what high-performing companies and organizations do versus what low-performing ones do. And then the second half of the book is all the science behind that. So it's really a great read to learn what to do, but also to learn why those things work. So first I want to talk about the speed of the high performers versus the low performers. So a low performing organization might be deploying once a month. So one of those speed metrics is deploy frequency, how often we're deploying. Whereas the high performers might be deploying as many as 10 times or more every day. At the same time, the lead time, so the time between when somebody commits a change into source control and when it gets deployed onto the site, that might be as long as 6 months for the low performers, particularly if they're shipping shrink-wrapped software or something like that, like I used to do. Whereas the high-performing organizations are maybe doing that every hour. So this is already a big distinction, and what the data shows is that there's not a clean spread of organizations across all these things, right? They tend to cluster in a low-performing group, in a medium-performing group, which I'm not showing, and in the high-performing group. So this is already interesting. But here's the other even more interesting and more powerful part. On the stability metrics, exactly the same high performers are in that upper quadrant, and exactly the same low performers are in the lower quadrant. So what do we mean by stability? The x-axis talks about change failure rate. So what is the percentage of time that we make a new deployment, let's say, and it causes a problem? So we have to roll it back, or we have to hot fix it, or something like that. And the low performers can be as bad as half of the deployments, almost half of the deployments cause a failure. Whereas the high performers are not 100%, but they get very, very close at the limit. At the same time, those same high performers and those same low performers differ from each other in terms of mean time to recover. So that's a metric that measures when there is an incident or an outage or one of these change failures, how long does it take us to repair or to recover from that failure? And so the low performers might take longer than a day to recover from a failure, whereas the high performers might be able to recover in less than an hour. So the crazy, non-intuitive, but wonderful thing is that if we learn how to be high performers, we're going to be better not just on the speed metrics, but also on the stability metrics. So it's extremely powerful and extremely cool. So here's another way of seeing what I said, but in quantitative numbers. This comes from the State of DevOps report in 2018. Oh, and by the way, the State of DevOps report for 2019 is about to finish, if it hasn't already. So if you haven't submitted your organization's experiences, whether good or bad or indifferent, please see if you can do that in the next day or two. So the elite, which is the highest of the high performers versus the low performers, they do this. So the elite ones are making 46 times more frequent code deployments. Their lead time from committing code to source control to deployment on site is 2,500 times faster. They have a 7 times lower change failure rate, and they are 2,600 times faster in terms of time to recover. So this is amazing. So if you're one of those low performers, maybe you're saying this to yourself. You're saying, well, I may be slow, but at least I do poor work. Cool. But what's wonderful is that if you're a high performer, you can get both speed and stability. And the metrics that I showed you, those 4 key metrics from Accelerate, are kind of engineering metrics, right? They're things that we use to measure ourselves, but directly those things don't have a lot of business value. So the other wonderful thing is that those high performers that are better on those engineering metrics are also 2.5 times more likely to exceed their goals in terms of business things like profitability and market share and productivity. So in case anybody comes away from this conference thinking, wow, I've learned lots of great ways to make better software, but I can't see how that matters in the real world, this is how it matters. Okay, so this talk is going to be in 4 different sections. I first want to talk about organizing for speed, how high-performing organizations do their organization. Next, I want to talk about the decision-making that we do about what to build, and more importantly, what not to build. Then I want to talk about when to build things, which is about focus and about prioritization. And finally, I want to give a few thoughts about how to build things. So was anybody here in the wonderful talk by Adrian Cockcroft yesterday that he called Speeding Up Innovation? Anybody in that talk? Great, looks like about a quarter of you. It was a wonderful talk. You should completely watch it on video if you didn't see it live. So one of the Adrian's wonderful and a friend, and he talked a lot about great things we can do in terms of software to move faster, right? So he talked about deployment systems, he talked about cloud-native architectures, he talked about microservices, he talked about a lot of great technical capabilities that you need in order to speed up innovation, or if I were going to say it, move fast at scale. So I believe all the things that Adrian said, but everything I'm going to talk about is in addition to what he said. So wonderfully, we don't overlap in any way. All these things are going to be more about the building the right thing than about the building the thing right. Okay, so let's start with organizing for speed. So in traditional organizations, when I started in the industry, which was quite a long time ago, I used to have hair, there used to be a team that produced ideas, and maybe we called them business analysts or product people or something like that, and then they handed some ideas over the wall to well-paid typists like us. We would type happily into our editors. For me, that was Emacs. Then after that, we would hand our software off to quality people who would make sure that the typing was good. And then at the end of the day, once it passed our quality measures, we would hand it off to some other set of people in our company or in some other company that would operate it in the real world. So it turns out that this sort of cascade, or dare I say, waterfall approach to software isn't really great in the real world. And what we've learned over those decades is this, that it's much better to have smaller teams that combine all those ideas of the idea people, the developers, the quality folks, and operations, put all those skills and all those responsibilities in one team, and but do them by individual domains, right? So not one big team for quality, but quality is part of every individual team as we produce different pieces of software. And why do we do this? We do this to go faster. And that's what these feedback loops are showing, is that we're actually able to move faster by having small teams with well-defined areas of responsibility with all the skill sets that we need within that team boundary. So people have probably heard this phrase of the 2-pizza team. It's credited to Jeff Bezos of Amazon. And he used to say that a team should be no larger than can be fed by 2 large pizzas. And I actually have to put a little bracket in there. It's 2 large American pizzas. Because I've given a very similar talk in Cuba, which was really wonderful. I gave it in Spanish, actually. It was a lot of fun. And when I got to this slide, they were a little bit confused, not because they'd never heard of pizza, but because they had the normal Italian, single-serving pizza. So they couldn't imagine how a team could be fed by 2 of those. Anyway, so I had to explain that, pizzas grandes americanas, are really large, and blah, blah, blah. Anyway, so it was quite fun, and we had a good laugh about it. Anyway, so 2 large American pizzas. Great. So the other aspect about these teams is we need to make sure that they're aligned to business domains that actually matter. So we don't want to form a team that's like the database team or the operations team. And I used to work in organizations that were like that. Instead, we want to form a team that's like the checkout team, the member acquisition team, right? The billing and payments team. So teams that actually that produce business value and are directly aligned with something that the business wants to do. So they're aligned around a business problem. They have clear goals and metrics, and that it's important that those metrics and those goals actually matter to customers. So if we produce those things, the things that we intend to do, that they actually directly lead to customer value. The other related notion here is that these teams now have well-defined areas of responsibility. And that's true for the business problem that they're solving, but that also can be directly reflected in the software that they produce. So done well, a team might produce a single application or a single set of related applications, or maybe a single service or set of related services. So individual teams wouldn't, in an ideal world, wouldn't be responsible for tens and tens and tens of different things to deploy, but rather a small number of things that directly align with the business problem they're trying to solve. And so when I've talked about this before, people ask me, well, this is really easy to see when we're small, but what happens when the team grows, like when we need to double the size of the team or something like that? Well, so the analogy that I like to use is cellular mitosis. So people probably, in some time, they've learned a little bit of biology, and so the biology of cells is that you start out with one cell. All of us at one point or another, started out as one cell, that cell divided into two cells, those daughter cells divided into, a total of 4 cells, 8, 16, et cetera. So that cellular mitosis is a great analogy for how we might split up teams. And we don't have to split teams into 2, we might split them into 3 or something like that. But that's the general idea. You don't typically need to reimagine the entire organization just because the billing and payments team has grown a little bit larger. Does it make sense what I'm saying? Great, thank you. And I am I once upon a time was a developer. I still consider myself an engineer. Mostly I'm a pointy-haired boss for the last while. So one of the ways that I measure myself is, have I formed my teams in a way that align directly with business objectives? And so a way that I might check myself is this. So this would be my ideal goal. It might not always, don't worry too much about the number, but if I can, success for me would be to form a team where maybe 80% of the work that team is doing is, squarely within the team boundary, and maybe 20% of the work is, crossing those team boundaries. I'm not super worried about the 80, 70 might be good, but definitely if it's like 10 or 20%, that reflects on me, and it means that I didn't draw those team boundaries correctly. So obviously I could never make this 100%, because by definition, the large strategic initiatives of my company are almost by definition going to cross a lot of team boundaries. Does it make sense what I'm saying? But in an ideal world, I don't want to have every single project or every single feature or every single deployment crossing many, many, many team boundaries. Again, why don't I want to do that? It's because I want to optimize the feedback loops, keep as much of the stuff within the team as possible so they can iterate rapidly and produce software very quickly. Okay, so the other organizational objective that I have is what I call autonomy and accountability. So again, as I mentioned, I want to give a team a very clear business goal, which is measured by clear metrics that matter to customers, and I don't want to give them a solution. So I want to say, here's the business problem that I want you to solve. Please figure out what's the right technological way to do it. I want to give them autonomy. So within that team boundary, it's okay with me if they want to organize themselves in a different way, as long as they produce those particular goals and they can do it sustainably. And I like to let the team own what's the best way to self-organize toward that goal. But also, at the same time, I want to make sure that I hold the team accountable for the results. So you need to have those two things together. If I give them autonomy without accountability, that's a child. So I'm a parent. I have a 12-year-old son who's both autonomous and accountable now. But when he was learning to walk, or when he was much younger, he was autonomous, right? He would wander around, by himself, but he wasn't really fully, accountable for his actions. That was my job as a parent. So autonomy without accountability is like being a child, but accountability without autonomy is like any one of those terrible big enterprise situations you might have heard about, not in your own company, I'm sure, but that you might have heard about where there was some dictate that came down from on high that said, you must do this thing, but you had no ability to influence that. Does that sound familiar to anybody at all? Yeah. Not I'm sure in your current job, but previous jobs that you've had before. Yeah, cool. So the idea is that I want to make sure that team is responsible for producing business value and also responsible for the results of their choices. Like if they make technology or process choices that don't work out, they should own it and fix things and make them better. Okay. So we talked first, the first thing we talked about was that organizational aspect. Now I want to talk about what to build and what not to build. And if you take away nothing else from this talk other than 7 words, I'm going to please let them be these 7 words. So I'd like you to remember, what problem are you trying to solve? This is a wonderful question you can ask yourself, and you should always be asking yourself that constantly within your team, but it's also a very powerful tool that you can use with the idea people, the business or product folks in your organization. So has anybody had an experience like this, where some product person or business person comes to you for your application, and they said something like, hey, Randy, could you just please have the team add this button? Anybody had that experience? Just add this button for me. Yeah, let the record show that almost every hand went up. Here's what you can say. Because they said please, so you should be very polite. You should say, could you please tell us what problem you're trying to solve? And what you are not saying is, no, I don't want to add the button. But what you are saying is, please help me understand the problem that you're trying to solve with adding the button. Because it may be through that conversation that you have with them, which could be 5 minutes or 10 minutes or half an hour. It doesn't have to be a lengthy conversation. But just to understand what the problem they're trying to solve, we might actually have a different way or a better way or a way that they hadn't thought of to solve the problem instead of adding the button. So let's dig into that a little bit, because I think we don't fully, as engineers, appreciate our own power, that we don't appreciate what we bring to the table. So I like to think about this in terms of engineering discipline. We bring a discipline of problem solving to discussions. So we might, and we do this for ourselves when we have a little rubber duck next to us to try to debug something. So as engineers, our training, whether formal or informal, is basically in what I'll call disciplined problem solving. So some of my friends know that once upon a time I wanted to be an international lawyer, and I actually studied law and international relations for some time. And I have a political science degree in addition to a degree that's mathematical and computational science. And I learned a lot of really interesting stuff in the mathematical and computational science part. I learned other interesting things in the political science part, but what I did not learn in political science is disciplined problem solving. Does it make sense what I'm saying? So there are business and product people that work with us that are wonderful and contribute a lot, but do not necessarily bring the same kind of problem solving approach that we do. That is our contribution. So it's our job to help in that conversation, to help the business person clarify what problem they're trying to solve. Does it make sense? Cool. A thing that has happened to me many, many times, and so it might have happened to you, is this idea, something called the curse of knowledge. So the curse of knowledge is that I have some understanding of how the software works and what are the trade-offs and options that we might have available. And the fallacy here is that I know that stuff, and I assume maybe other people on my team and the business people also know those things. Who thinks that the business people in their organization know all the trade-offs and options that you have in your head? Let the record show that no hands went up. And again, that is not because the business and product people are terrible or not smart or aren't not contributing, but that's not their job. That's your job. So we are the ones that understand the options and the trade-offs for adding the button or changing the configuration or whatever we would do technologically to solve the business problem. We understand those options, and it is our job in that conversation to make sure that the business people also understand it. So together we can make the right trade-off and make the right decision together. The other aspect about fully understanding the problem is this idea, is that engineering is about solving problems, as I just said, but only sometimes do we solve those problems by writing code. I used to work for an American apparel manufacturer, a retail company called Stitch Fix. So we had physical warehouses where we stored the clothes. And one of my teams built software that would operate the warehouses and that the warehouse people would use to get their jobs done. So we had exactly the situation that I was describing earlier, where the warehouse people came to us and said, hey, could you please add a button, because we're changing our process around, and can just add a button or add a new step in the workflow over here. And as we talked through the problem, it just became very clear that if we changed the business process slightly, like if we just did one thing before the other thing, we didn't have to change the technology at all, and everything would be much more efficient. And just simply that kind of rubber duck, forcing let's say, encouraging that conversation between the business or product or customer folks and the engineers was a way to elicit that. And everybody came out of that conversation a lot happier because we ended up simplifying the solution. So again, I will say that our job as engineers is not to produce software. Our job is not typing. That is a means to an end. Our job is to solve problems. Okay, the other reason that we really want to understand the problem is this. So Mary and Tom Poppendick in 2003 wrote this wonderful book. They are both here at this conference, so you should say hi. They are wonderful and warm people, also brilliant. So of the many things that are wonderful about this book, and if I could give a sidebar, this book was written in 2003. If you read this book right now, you could not imagine that it was not written in 2019. I mean, it is incredibly prescient, incredibly modern in all of the software techniques. The only thing that might be a little bit, seem a little bit, 16 years old is some of the engineering examples, but everything, the 99% of the book that aren't like specific examples are incredibly timeless and incredibly modern. And I have to give them so much credit because they saw this before really anybody. Okay, they talk about the 7 wastes of software development. The first, number 1, is building the wrong thing. And so fully understanding our problem is a way that we can hedge against building the wrong thing. Does it make sense? If we fully understand our problem, we are much less likely to build the wrong thing. And why do they call this the biggest waste in software development? Well, I guess we could ask them, but if you ask me, I would say it's because if I'm building the wrong thing, then 100% of my effort is wasted. Does it make sense? Like there are lots of wastes, right? But there's only one waste that's like 100%, and this is it. Cool. Okay. If I have not convinced you that you should understand the problem, I'm going to give you more ammunition. Another reason to understand the problem is it gets us a lot of the way toward the solution. So this is Charles Kettering, who was the head of research for General Motors for many years, and he liked to say, a problem well stated is a problem half solved, right? So as we go through, as we solve our problems as engineers, a lot of times the first thing that we do is sit down, even if we're not talking to a business or product person, is try to fully understand the problem and break it down into individual steps so that we can solve it in a good way. That means that even our practice of software development is trying to make sure that we fully understand the problem as the first step. So when I have fully understood very deeply a problem, why it's important, and what's involved in there, that gets me much of the way toward the solution and makes actually all the typing that I'm ultimately going to do a lot easier. Does this make sense? Great. Okay. So now we have talked about what to build and what not to build. Now I want to talk about when to build things. And when I say when, I mean this area of focus and prioritization. So please raise your hand if you have more time and resources to do all the things you're supposed to do. Let the record show, Your Honor, that no hands went up. Right, because we always have more to do than resources to do it. This is actually physics, so there's like nothing weird about that. This is just the state of the world. And so as a consequence, the logical consequence of that is because we can't do everything and because we have scarce resources, we have to prioritize, right? So we can't do everything. We have to choose a small number of things out of the many things we could do to actually do. And so that implies that every time we decide to do something, we're making a trade-off. We're deciding to do this thing, and we're deciding not to do another thing. And so the wonderful phrasing that comes from economics is this idea of opportunity cost. So the direct cost of something is very clear. So if I do X thing, it's going to cost me this amount of engineering time, this amount of physical compute resources, blah blah blah. So that is very easy to measure. But the thing that we don't always have the discipline to do is that by choosing X, we don't just accrue those direct costs. We also accrue what are called the opportunity costs of all the decisions that we decided not to do. Does it make sense? By choosing to do X, we are actually explicitly, choosing not to do Y, not to do Z, not to do W, etc. And as part of making that decision, we need to understand, well, what would have been the benefits of doing, what did I say, Y or Z or W, and that has to factor into our decision as well. So I asked you to remember the 7 words of what problem are you trying to solve. If you can hold 4 more words in your brain, I'm going to ask you to remember these ones. Fewer things, more done. So maybe you're noticing that I like to say lean software ideas, but I like to say them in really simple, stupid language, because that's the only way my brain can absorb them. So this is limiting work in progress, right? But I find it a lot easier to say and to remember fewer things, more done. And both things are important, right? I want to do fewer things at a time, which we're going to talk about, but I also want to get more of them done. Okay. So again, let's contrast traditional organizations, or those low-performing organizations, with the higher-performing ones that we'd like to be. So in traditional organizations, let's imagine we have a 5-person team, and of course, as we just learned, we have more than 5 things to work on. So let's choose the 5 most important, features to do or whatever, and okay, we have 5 people on the team, so that, the sort of intuitive thing to do is, well, let's put, person 1 on feature 1, person 2 on feature 2, et cetera, et cetera, et cetera. And I will openly admit that until very recently, this is exactly how I managed my teams. I bet we could do better than this, though. So one way we could do better, and remember we have these things in priority order. So one way we could do better is this, is what if we, instead of having only 1 person work on feature 1 and get it done 4 months from now, what if we had maybe 2 people work on feature 1 and 2 people work on feature 2 and actually get it done in half the time? Now, the asterisk here is, of course, not every problem is amenable to that. Some things can only be done by 1 person at a time. That's totally fine. But I have found that more than almost all interesting features can be contributed to by multiple people at the same time. So this is a common case rather than a rare case. So let's imagine, again, with those same 5 people and those same levels of difficulty of the features, we're going to do the very highest priority thing first with 2 people, let's say. We're going to do the very next highest priority thing, number 2, as feature 2, and then the 5th person we can have on feature 3. And then when those other, feature 1 and feature 2 get finished, as we hope, we're going to start feature 4 and feature 5. Now, why is this better? One of the reasons is that we've actually started producing value, right? We've produced value at, in this example, 2 months as opposed to 4 months, so that's really wonderful. But also, we are very explicitly optimizing for producing the highest priority things first. Does it make sense? In the previous example, feature 1 and feature 5 we're treating the same. That's stupid, because there's a reason why we called feature 1, the highest priority. Great. So better, it would be to do something like this. And so, the quip that I like to use here is, once you've done those first things, you can do the next. Or, as I like to say, once you solve problem number 1, problem 2 gets a promotion. So I think we can do yet better. So even better is if we, instead of working on a feature and only releasing it at the end, in this example, 2 months, what if we thought a little bit up front and we broke the feature development down into small individual chunks that we could release, incrementally? And so maybe maybe we could break this particular first feature up into 4 chunks, each of which we could deliver. We could maybe break the second one up into 3 chunks, whatever. It does require a little bit of thinking up front, but as I hope you've learned from this conference and many others, agile does not mean not thinking. So what are some advantages of this? Again, we are producing customer value earlier. So we're producing, we're not done with feature 1, but we're producing incremental value along the way. That's great. The other thing, though, is we are giving ourselves the option value to change along the way, right? It's possible that as we release the A part of feature 1, then the B part, then the C part, maybe we realize when we get to C that C is all we need. Or maybe more likely, it would be nice if we did D, but it's even more important that we do something else at the moment. Does it make sense what I'm saying? So it gives us, by not doing one big leap, instead by taking individual steps along a path, we actually give ourselves the option value to learn over time and shrink those feedback cycles so that we can do actually the best thing. The other thing we could possibly learn along the way is maybe feature 1 isn't all that interesting. Right? So maybe we abandon it at some way along the way because we find that what we used to think of feature 4, maybe that's more important, something like that. But if we've done this, at least we have produced value along the way, and that value can continue to be there. So again, if we take this incremental approach, one of the wonderful things is that we can be resilient to this idea, where we get changes in priority along the way. Does this make sense? So let me summarize what we just did, as we took a kind of low-performing traditional organization into a more modern, lean, agile type of approach. So the first thing is we delivered the highest priority features first, right? So we did not treat priority 1 and priority 5 the same way. We delivered the full value earlier, right? So of those features, in our example, we delivered feature 1 and feature 2, at the second month mark. So we delivered them earlier, and because, as people are probably familiar, there's this time value of money. So 100 euros right now is much better than 100 euros a month from now, or 6 months from now, or a year from now. The same thing is true of features. We have delivered, by doing things incrementally, we've delivered value along the way, and we've given ourselves the option value to learn and to change priorities. And also, the other thing is that when you have two people together, just like we can be the rubber duck for the product or the business person, by having two people work on the same feature, they can be rubber ducks for each other. Does it make sense? So when I run into an issue, well, let's say it this way. Who, as a software developer, has been working along on something, and then you just get stuck and you're not sure where to go from there? Let the record show that basically everybody's hand went up, because that is the practice of software development. It's the same as the practice of writing, right? Writer's block. So when you get blocked, obviously you can go away and come back and think, but if you have somebody else that's there that can help you, that can unblock you really quickly and help keep moving things forward. Great. So I want to give two examples of where I've done this approach in my career. So I used to work at eBay as the chief engineer for a long time, and one of the things we did in 2011 was we introduced the idea of machine-learned ranking. So people are probably, I worked on the search engine at eBay, and people are probably familiar with the idea that a search engine has a ranking function. So that's the function that scores the results and decides what thing to put in position 1 versus position 10 versus whatever. Okay, so and initially at eBay, there was the ranking function was sort of a handwritten linear combination of a small number of factors that was written by a product manager, and that product manager was very talented and very smart, but we thought we could do better. So our hypothesis was that if we used machine learning, we could maybe use hundreds or even thousands of factors and make a better decision about ranking for the particular set of items, for the particular query, for the particular user. We thought we could do better than this blanket thing that somebody wrote a bunch of years ago. So we set off and incrementally experimented. So we were running hundreds of parallel A/B tests all the time. So we had the old version of the ranking function as our control, and we would be constantly tweaking little aspects of the ranking function. Most of those tweaks made things worse rather than making them better, so we wouldn't do those again. But the things that made us a little bit better, we would sort of bank those and continue on and make further improvements and further improvements and further improvements. So after a full year of those steady incremental improvements, the result for the business was this. This work alone, which was about 15 or 20 people's worth of work for a year, generated a 2% increase in the overall revenue of the entire company, eBay. So at the time, it's much larger now, but in 2011, eBay's revenue was about 60 billion, eBay transacted about 60 billion US dollars worth of merchandise every year. And so given eBay's cut of that, the incremental improvement in revenue was $120 million every year. So that felt pretty good. Here's what else we did. At the same time, but an entirely different team focusing on an entirely different area of search, we were trying to improve the speed of the search pages. And so our hypothesis here was that rather than adding more and more and more features, what if we took a pause and, well, we could still add features, but what if we also tried to speed up the experience itself? So what if we actually made the website faster? And as a side note, it was, in retrospect, this was obvious, but it was mind-blowing to me at the time. It was surprisingly difficult for me to convince the product and business people that I should spend a team's time on not adding any new features, but simply making the existing features faster. Our hypothesis was that by making the pages faster, people would buy more. Well, let's see if that worked. So again, we went through an iterative process. We did all the, Steve Souders, faster websites, even faster websites, techniques. We would implement a potential improvement that we thought would improve site speed, leveraging the CDN better, moving the JavaScript around, et cetera, et cetera, et cetera. We would release that to the site in an A/B test. And then we would monitor the metrics. So we would have metrics of, very detailed metrics of time to first byte and time to click by the user, et cetera, et cetera. And obviously, we're also tracking the revenue that was associated with the newer version versus the older version. And so again, on top of the 2% we got on the previous slide, we got another 2% increase in the overall revenue of the company. So again, another 120 million US dollars every year. So in combination, in 1 year, with 2 relatively small teams making incremental progress in these 2 areas, we made basically $250 million for eBay, and they could get that every year and every year and every year. Pretty cool. Okay. So the last thing I want to talk about is a few thoughts on how to build things. And the thing that I particularly want to do here is this. So who has ever heard this? We don't have time to do it right. Wow, let the record show that basically everybody's hand went up. Well, so here is what you can do. You can say this: do we have time to do it twice? That is the choice. I'm going to talk about what right means, because I don't mean perfect. But if I don't do something well enough the first time, for sure I'm going to have to come around and do it again. And interestingly, and maybe counterintuitively, the more constrained that I am in terms of time and resources, so maybe the smaller of the team that I have, the earlier that I am in my kind of cycle as a company or as a product, the more important it is for me to get it done the first time. So I particularly want to appreciate that in this part of the world, there is more a fear of the pathology. The dysfunction is more over-engineering than under-engineering, and I will say openly that where I come from, the dysfunction is mostly under-engineering, but let's just know that. But at the same time, I think we can come to a happy medium, and that happy medium is this. So people are probably familiar with Eric Ries's idea of the minimal viable product. So I'm going to borrow, I'm going to steal that same idea for this, and let's think about what is the minimal viable feature. So obviously, we need to have understood what problem we're solving to really understand what we mean by minimal and what we mean by viable. But this is the key, is that try to figure out, not build the perfect feature, not build it where we would never ever want to make any more improvements to it ever again, but understand what is the minimal capabilities that the user wants to get out of it, and what is the most viable implementation that I can do to make sure that that happens in a reliable and high quality way. So what do I... And that isn't just important for us as engineers, it's also important for our users. So probably all of us carry supercomputers around in our pockets that we call our mobile phones. Maybe the last time that you updated your operating system, I wonder if you said something like, wow, I see that 12.3 of iOS just came out. It looks like there are 57 new features in there. That is awesome. I'm so happy for all of those 57 new features. Said no one ever. Instead, you are probably actually happy about a small number of those features. So even to users, it's much more important that we build one great thing than we build 2 half-finished things. So the key thing that we want to ask ourselves in terms of building a minimal viable feature is how do we craft ourselves a definition of done? How do we decide when we're done for now, and then maybe we can come back later and do more and make it fancier if that's what the need is? And again, I want to be very clear that doing it right, in my opinion, being done doesn't mean perfect and that we're never going to want to make improvements to it. The question that we want to ask ourselves is, again, another one of those economic questions, which is trading off the marginal cost of more polish, more beauty, more whatever, things that we would do where we would never want to touch it again, versus the marginal benefit. Does it make sense what I'm suggesting? Think about, well, okay, if I kept working on this for several more weeks or several more iterations or whatever, how much better would it be? Would it be a lot better? Would it be a tiny bit better? That's the question that we want to keep asking ourselves as we prioritize along the way. And when we have a conflict, when we decide, you know what, we really want to make sure that we get something out, I want to strongly encourage you to reduce the scope rather than reduce the quality. Does that make sense? Cool. So you will have, I'm sure, your own definition of done. This is something that I put together, I with my team put together in our context. So we want to make sure that every feature we build, in a sort of minimal viable way. We want to make sure that we have automated tests associated with that feature. We want to make sure that it's released to production. We want to make sure that the feature flag is turned on, because we use that. We also want to make sure that it's sustainable and therefore monitored in production. You might want to add a bunch of other things like tracking the user behavior, for usage, et cetera, et cetera, et cetera. But I can't tell you how many times I've had this conversation with people, like, oh, hey, how are you doing with feature XYZ? Oh, I'm done. Cool. Did you test it? Oh no, I haven't done that yet. All right. Cool. Okay. Well, so then the next day or whatever. Hey, how's it go? How's feature XYZ going? Oh, I'm done. Is it released to production? Oh no, I haven't done that yet. All right. Okay, so the next day or a couple days later, like I'm not really such a micromanager, but let's pretend I am for this story. So I see the person the next time. I'm like, okay, I just heard we did the released things to production. That's great. Sounds like feature XYZ was in that. Fantastic. So are we all done? Oh yeah, we're all done. Well, is the feature flag turned on? Oh no, we haven't done that yet. All right. So you can see, like, the reason why I say it this way is not because. Well, let's take a step back. What are we trying to do? We are trying to deliver value to customers. Is there value if I have not written the feature? Well, clearly no. Is it sustainable if I haven't written automated tests? It's not very sustainable. Is it providing any value to the customer if it's not released? No. Is it providing any value to the customer if it is released but not turned on? No. And is it sustainable if I haven't monitored it? Also no. So the way to think about the definition of done is what is the minimal viable piece of value that I can produce to customers, and I actually produce it to the customer. Does it make sense? That's the only done that matters. And by the way, back to wastes, if we get all the way here and we don't release it, every single moment that we spent thinking and planning and typing this was a waste. Yeah? It was a complete waste. Maybe we learned some stuff, but you know what I mean? Like, we have not produced any direct customer value if we don't release it to production, turn it on, et cetera. So I can't emphasize that enough. We are not done until the customer can see it and can actually use it. Okay, cool. So we talked about organizing for speed. We talked about what to build and what not to build. We asked ourselves the question, what problem are we trying to solve? We talked about when to build things, and we gave ourselves that little mantra, fewer things, more done. And then we talked about how to build things, and we raised up the trade-off of doing something well versus doing something, half. So thank you very much.
Thank you, Randy. I believe we have a couple of minutes for questions.
Oh, yeah.
So let's go.
Yeah. Oh, I thank you so much for asking that question. I always get that question. It's fantastic. How in the world did I contribute the 2% of revenue? It's because we actually did a proper A/B test. So we were, in both cases, we were running in the machine learned ranking case, we were running the old ranking function for some percentage of traffic, and the way we were doing our results, how do we even know we were making improvements? It's because for another set of traffic, we were running a different ranking function. Does it make sense? So at the end of the year, we still had the old thing, and we could compare it very directly that we were making 2% more revenue with the new, shiny, hyper-improved machine learned one versus the old one. And we did exactly that same thing with the search pages. So again, we had a version of the search page that was the old version, that was the old, slow, clunky one, and then the very fast, streamlined one that looked exactly the same but was much faster. So the one was the control and the other was the experiment group. Does that make sense? So the only way that you can really make these determinations statistically is by doing things in an A/B way. Great. Thank you for that. Why do you think we have the same problems as 15 years ago, as the book describes, and not evolving into solutions? That is an excellent question, and people asked me a very similar question in a different context. Yesterday when I gave my talk about engineering history, I I would love to know the answer to that, because I think if anybody cracks this code, we will all be much better off. I think part of it, is that a lot of these things are provably correct, but they are not intuitive. Let that sink in. These techniques that I'm suggesting, and the other techniques that Adrian was suggesting, and all the techniques that you'll find in the Accelerate book, they are provably correct, because that's the whole second half of the book is about why these things work, but they are not intuitive. Nobody is born knowing how to do software development, and so I think that's part of it, is that people, mostly we're winging it, and yeah, so there you go. All right, this is all fantastic. Engineers will love this, but how do you bring this culture to the whole company? Great. Well, I think there are lots of different ways to do it. Number one, not to keep plugging this wonderful book, but Accelerate is readable by everybody. It's very intentionally readable by everybody. And in particular, they were quite smart, and they said, if you only read the first chapter, you're going to learn all the stuff. The rest of it is more refinements on those ideas. So one thing you could do is ask your business partners to read the first chapter of Accelerate, or the first chapter of Lean Enterprise, for that matter, which Jez also worked on. But the other way to do it is modeling it in terms of that what problem are we trying to solve conversation. Does it make sense? So when, not if, when your product or business partner comes to you and says, please add the button, you start that conversation of what problem you're trying to solve. You do that in a very helpful, very collaborative way. You guys both come out of that, you people both come out of that conversation hopefully feeling better about the solution, and then we'll model that, and so that problem solving, specifying the problem very clearly kind of gets pushed upstream. That's one of the ways I like to do it. You said that teams need to be aligned around a business problem, but what about some things like components, systems, internal tools that still require an owner but don't fit into a business problem? That is great. A great analogy for that is those components and systems that you produce, I'm sure you're producing them for a very good reason, but a lot of them you could maybe buy from a third party. And I use that just as an analogy. That is their business model. Your developers are their customers. So the analogy here is there is a business problem, which is indirect, that I want my developers to be more productive. So the team that produces the software infrastructure, that produces the development tooling, that produces the things that we build our software on, the platform, something like that. Those are not directly aligned with the business problem, but only one step away. And because they are empowering the developers in those other teams, they're helping out. And again, the analogy is, would we be willing to buy that from another company? Okay, conceptually maybe we couldn't, but conceptually maybe we would like to do that. And that company, that's the business problem that they're solving. Does it make sense what I'm suggesting? Cool. I am out of time. Thank you very much for your attention, and enjoy the rest of the conference.
Thank you very much, Randy.